deal. In fact, this is the single largest order by one airline for new aircraft that has ever been placed, being ordered by Air India.
India has just revealed something that has sent shockwaves through the global aviation industry. It is not a missile nor a space shuttle, but something else entirely. A $13 billion aircraft that does not obey the usual rules of science. It moves in ways that experts cannot explain. It performs at speeds that should not be possible, and the materials used to build it, they are just as mysterious. What is this machine really designed to do? And why is India suddenly taking a giant leap ahead of everyone else? Stay with us, because we are about to show you everything. The aircraft that shouldn't exist. When most people hear the word aircraft,
7 years of backlog. They can produce these planes as quickly as they can get engines. And as quickly as they can produce them,
they think of something familiar like wings, engines, a cockpit, maybe a tail. But this new Indian model challenges nearly everything we associate with modern flight. It doesn't follow the traditional shape of a plane. It doesn't have visible turbines or even jet engines. From the outside, it looks more like a large, smooth pod with no obvious moving parts. Far away from public eyes, in a part of India rarely seen by the outside world, something spectacular has been taking shape. For years, it remained hidden under layers of silence and steel. There were whispers, of course. Unconfirmed reports about a secret program. Occasional satellite images showed unfamiliar shapes parked near hangars. But nothing solid ever came out until now. India has officially unveiled a new aircraft. But calling it just an aircraft would be misleading. This machine does not fit into any category known to modern aviation. It is not a fighter jet. It is not a bomber. It is not a transport vehicle. And it is certainly not a prototype copied from someone else's blueprint. What we are looking at is a new class of aviation entirely that does not follow the limits that defined every aircraft before it. At first glance, the design looks almost alien, since there are no visible cockpits or traditional wings. The surface is smooth, curved in places you would not expect, and sharp where it should not be. There are no markings or symbols that hint at its purpose. It does not look designed to carry people, yet it seems more advanced than any drone. No smoke trails follow it. No ordinary engines hum beneath its frame. The aircraft appears to float, not fly, and when it moves, it does not roar, but vanishes. Those who have seen it up close describe something eerie about it, as if it weren't built by hand, but grown in a lab. Everything about it looks too perfect. Every edge blends into the next with no bolts, no seams, no hinges. And yet, despite the absence of all the things that normally keep an aircraft together, it holds up under pressure. It slices through thick air. It performs maneuvers no known jet can perform. At speeds and temperatures that would normally tear metal apart, it stays intact. So, what exactly are we dealing with? According to sources within India's Defense Research and Development Organization, this $13 billion machine is not based on any existing aircraft design. It was built from the ground up using materials that have never been used at this scale, powered by systems that have no precedent in civilian or military aviation. And the way it behaves in flight, the way it bends, accelerates, and shifts, has led some observers to say, without hesitation, that it defies the laws of physics. That's a big claim. And India is not the type of country to make such claims lightly. Which raises the question, why build something like this in the first place? What is the real purpose of this aircraft? And how did India, a nation once dependent on imported jets, suddenly leap so far ahead? To answer those questions, we have to go back. Not just a few years, but decades, to the quiet beginnings of a dream that would one day reshape the future of flight. A dream that took root in silence. It did not begin with a big announcement, since there were no flashing lights, government statements, or a public countdown. In fact, the early days of this project were so quiet that most people inside India's own defense circles had no idea it even existed. At the time, India was still wrestling with outdated jets, borrowed designs, and technology deals that placed limits on innovation. Every step forward felt like a step under someone else's shadow. But there were a few minds who refused to accept that. Somewhere deep within India's research institutions, a small team began asking dangerous questions. What if an aircraft didn't need engines the way we know them? What if lift could be generated through force fields instead of wings? What if speed wasn't the goal, but seamless transition between air and space? It sounded ridiculous to many since it was too ambitious and risky. But to this small group of scientists, engineers, and dreamers, it was a challenge worth exploring. Not for glory, not even for war, but to prove that India could become a place where the future wasn't just observed, it could be shaped. So, without drawing attention, they started. In empty labs with second-hand equipment. In conference rooms with nothing but notebooks and conviction. There were no clear blueprints or a rule book. They had to invent everything as they went along. The mathematics alone was brutal since the materials they needed didn't exist yet. The prototypes failed over and over, but each failure taught them something new. Then came a breakthrough. In 2015, one of India's leading metallurgical institutes discovered a way to bond ultra-lightweight carbon with a rare earth alloy under extremely high pressures. The result was a substance unlike anything they had ever seen. It was lighter than aluminum, stronger than titanium, and could survive temperatures that would melt traditional metals in seconds. More importantly, it could flex, just slightly, without breaking. It moved like bone. It absorbed force, like skin. Suddenly, the dream started to take form. With a new material in hand, the team shifted focus. They no longer needed to follow the design patterns of existing jets. They could build something new, something shaped not by old rules, but by the possibilities of this strange new metal. Simultaneously, another team in Bangalore was experimenting with magnetoplasma propulsion, a type of engine that uses electric fields and charged gases instead of fuel. At the time, it was a concept and a theory. But when their data began to align with the structural properties of the new alloy, things moved fast. Top-level defense officials were brought in. Funding was approved in silence. Facilities were cleared and repurposed. And just like that, India's most secret aviation project was born. It was called Project Vajra, named after the ancient weapon of the gods, believed to be indestructible and capable of destroying ignorance. Fitting, because this aircraft was never just about flight. It was about breaking mental boundaries, about building something not because it was safe, but because it was thought to be impossible.
The aircraft incorporates composite materials, improving durability and safety. Its large, strake, and blended wing body design generates lift air vortices, enabling sustained maneuvers at specific angles of attack.
Years passed and people changed, but experiments continued behind reinforced walls. Every now and then, rumors slipped out. Engineers would quit, claiming they had worked on something not from this earth. Scientists would vanish into defense labs and never publish again. But no one had proof. No one had photos. Just whispers and blurry outlines on satellite feeds. Until now. Project Vajra has stepped into the light. But what lies underneath its curved frame and silent engine still raises more questions than answers. One thing is certain. This is not just an aircraft. It is the result of decades of silent defiance, of minds that refused to believe that the laws of physics were untouchable. And now that it's here, the world is watching. The sky cracks open. The first test flight was never meant to be public since it took place at a sealed facility in the Rajasthan desert, where the air hangs dry and the sky stretches wide and empty. Security was beyond strict, as satellite feeds were jammed, air traffic around the perimeter was rerouted, and even ground-level activity was masked as routine military drills. Only a handful of people were allowed to witness what was about to happen. Most of them didn't speak. They simply stared at the object that sat motionless on the runway. It was an aircraft with no visible engines, no tail, and no seams. just a smooth, dark body that shimmered slightly under the rising sun. Then, without a single puff of smoke or flame, the aircraft rose. It didn't roll forward like a jet. It didn't gather speed or roar into life. It simply lifted silently and effortlessly, as if the rules of gravity had been rewritten. 1 second it was sitting still, the next it was hovering 15 feet above the ground. The observers were stunned. Even birds that happened to be flying nearby scattered in confusion. There was no blast, no jet wash, no sound waves thundering through the air. Just a low hum barely audible like electricity vibrating through a crystal. The aircraft tilted slightly, then moved forward. Slowly at first, almost cautiously, then faster. It reached the edge of the testing zone in under 10 seconds and vanished into the sky. Every tracking system lost it immediately. That was when the real panic started. Not among the Indian officials, but far outside the base, in countries that weren't supposed to know about the flight. Within hours, foreign intelligence satellites repositioned over Rajasthan. Signal interception units scrambled to listen for telemetry. Infrared scans showed a sudden burst of plasma signatures high above the desert, like spikes that didn't match any known aircraft. By nightfall, India had received more than a dozen indirect diplomatic inquiries. There were questions regarding what was flying over India's airspace earlier, if it was part of a satellite test, or if they encountered an unidentified object.
The Air India deal. We told you about this yesterday, but we want to discuss it again today because so much has happened since, and there's so much to be told. This is the mother of all aviation deals. Air India is an Indian carrier, now a private Indian carrier. It has placed a massive order.
Yet, with all the questions around, India said nothing. Inside the base, though, the reaction was very different. Engineers cheered, scientists cried, and a general reportedly fell to his knees and whispered a prayer. Since what they had just seen wasn't merely a successful test, it was a moment that changed everything. The aircraft had not only flown, but it had also responded to neural controls. Pilots inside the cockpit didn't use joysticks or throttle levers. They wore a headband that read electrical impulses from the brain. Thoughts were translated into movement. Tilt, accelerate, hover, ascend, and all were triggered through focused intention. And even more surprising, the aircraft didn't burn fuel in the way traditional jets do. Its energy came from a compact power core that used a plasma electric generator, shielded in graphene and cooled by a fluid system that could survive temperatures of over 2,000 degrees. In other words, it didn't need to land to refuel for hours, possibly even days. That first flight lasted only 12 minutes, but in those 12 minutes, India had sent a message not with words, not with speeches, but with action. The sky was no longer a limit. It was now a test bed. And this was just the beginning, because the real surprise wasn't how it took off, but where it went next. What is this aircraft really? For days after the test flight, top engineers across the world stared at data they couldn't understand. There were heat trails, magnetic field disturbances, and atmospheric ripples. Everything pointed to the same conclusion that this was not a regular aircraft. It didn't behave like a fighter jet, didn't leave the kind of residue a missile would, and didn't match the signatures of stealth planes developed by the US or China. Whatever India had flown over the Rajasthan desert, it was new. And possibly something that hadn't been seen before by anyone or anywhere. This aircraft wasn't designed to fight. It wasn't even designed to spy. Its purpose was something far more ambitious, to break the limits of human flight entirely. The structure of the aircraft alone was a puzzle. Unlike modern fighter jets that rely on aluminum alloys and carbon composites, this one used an entirely different material, which is something the Indian team referred to only as black kavach. It wasn't just heat-resistant. It was energy-conductive, bullet-absorbent, and more importantly, self-healing. During simulated impacts, the skin of the aircraft showed the ability to seal micro-tears in real time. Not weeks nor days, but seconds. Its body also didn't follow the traditional wings and tail layout. Instead, it had an organic shape, closer to a manta ray than a fighter jet. Smooth curves, no right angles, and no visible seams. This wasn't a design optimized for radar evasion, since it was a shape meant to manipulate airflow at a molecular level. Hidden within its shell were thousands of tiny directional vents, each no larger than a fingernail, that could open and close within milliseconds, shifting air pressure, stabilizing its position, and guiding the aircraft like it was swimming through the air instead of flying. Then, there was its control system. As mentioned in the earlier test, this aircraft responded to brain signals, but it didn't stop there. Every surface inside the cockpit was coated in smart touch graphene panels. The pilots wore suits embedded with nanosensors that could measure heart rate, oxygen levels, and neural wave activity in real time. The plane wasn't just being flown, since it was learning the pilot's body, matching its behavior to their state of mind. If the pilot panicked, the aircraft automatically engaged stabilizers. If the pilot focused, the aircraft sharpened its sensitivity. It was the closest thing to a symbiotic machine, as a craft that didn't just obey commands, but understood them. But where did this technology come from? Publicly, India has long been known for its advances in space tech. ISRO, the country's space agency, has launched lunar missions on budgets smaller than Hollywood movies. Indian engineers have mastered miniaturization, efficient propulsion, and low-orbit orbital insertion. But this project was something else. It didn't come from a civilian lab, but from a closed-loop military tech initiative, hidden deep within the Defense Research and Development Organization. Leaked documents hint that the origins of the aircraft date back nearly 2 decades, when Indian scientists first began experimenting with quantum magnetics and controlled plasma field emissions. The goal was never to simply make another jet. The goal was to explore a theory that questioned whether gravity could be bent using controlled electric fields and dense magnetic cores. Most mainstream physicists laughed at the idea. They said it would never work. But now, many of them have gone silent. Because if this aircraft truly flies the way reports suggest, without traditional fuel, without combustion, without moving parts, then it means one terrifying thing. India may have just stepped into a new age of propulsion that the rest of the world hasn't even started to study. And that brings up a dangerous question. If India can build one of these, what else can they build next? Global reactions and the secret race to catch up. When news of India's new aircraft started circulating, many outside observers were skeptical. At first, some thought it was just another experimental drone or a test model. The video showed a smooth, quiet flight without any visible engines or wings, which is something unusual, yes, but hard to believe without more proof. Still, experts around the world began paying attention. Governments and military agencies started reviewing the limited data available. In the United States, analysts studied satellite images and signals. They noticed unusual heat signatures and electromagnetic patterns that did not match any known aircraft. Meanwhile, in China, security agencies quietly investigated. They tried to learn if any technology or research had leaked from Indian labs. But so far, India's project remained tightly controlled, with no clear signs of information leaving the country. European aerospace engineers also examined the details. They were surprised by the design and materials used. India seemed to have developed something different from traditional jets, focusing on new materials and propulsion methods. The project's secretive nature raised questions. Was this aircraft meant for military use, or did it have other purposes? Some experts believed it could change how fast people travel, while others focused on its potential defense applications. International discussions started, mostly behind closed doors. Smaller countries asked about the implications for airspace safety and security. If India's aircraft could fly faster, quieter, and with less detection, how would that affect global travel and military balance? In the US, a special research program was launched to study similar technologies and catch up. Known internally as Shadowbird, the project aimed to better understand new propulsion systems and materials like those seen in India's aircraft. Russia also followed the news closely. Officials there considered the possibility that India had made a breakthrough in propulsion or materials science. Some wondered if the project involved any cooperation with outside groups, though there was no public evidence. The aircraft itself did not need to carry weapons to be significant. Its capabilities alone could influence global military strategies and future aviation developments. For the first time, India appeared to be leading in a highly specialized area of aerospace technology. Other countries now had to accelerate their own research to keep up. This development marks a shift in the global technology landscape. It reminds the world that innovation can come from unexpected places and that every country with a strong research culture can contribute to the future of flight. India's new $13 billion aircraft is unlike anything the world has seen before. It challenges what we thought was possible and pushes the limits of science and engineering. This breakthrough could change the way we travel, defend, and explore the skies. What will this mean for global aviation in the coming years? Could other countries catch up, or has India taken the lead for good? Let us know in the comments section. We hope you enjoyed watching this video. Remember to like, share it, and subscribe for more. Also, click the next video showing on your screen. You will enjoy it.